Thank you very much for Sistema to invite us to the webinar. And hello, everyone in India and Russia who is watching. My name is Jeroen Brouwer. I'm manager of custom program management within TomTom. I have a background in traffic engineering. So as you can imagine, the content of this entire webinar is extremely interesting to me. In this 20 minutes, I will give you a quick introduction in the world of floating car data, what kind of solutions you can make out of that, and different use cases around the world where this is already applied, hopefully giving you some inspiration to everything that's possible. Well, before I go into floating car data, just quickly, who is TomTom? Because you might know TomTom from the past as a consumer company, but TomTom made in the last 10 years quite a big change. We really went from a business to consumer company to a business to business company specialized in mobility and digital maps. Nowadays, you can find TomTom embedded in many different smartphone apps and cars, but you don't see the brand TomTom. And that's because we made quite a significant change in strategy. Well, first of all, TomTom, the fuel of this company is data. I can really say this is a big data company. And to give you an idea, I have a little movie. This is for Amsterdam, but just imagine the technology works exactly the same in both India and in Russia. Because what we do as TomTom is that we collect floating car data. We collect GPS data from moving devices. And what you see in this movie is in the historic center of Amsterdam, you can see all the devices moving around. All of the data that TomTom is collecting is completely anonymized to make sure that we respect the European privacy law, but still we can obtain some really interesting information. And the basis is quite simple. So people drive around with a connected car, with a smartphone app or a navigation device, and every second it stores your GPS position. That GPS position is shared with TomTom. We can map match it, and based on that, we know the speed and the travel time throughout all the road segments, which we use for real-time solutions, for analytic solutions, but also to update our digital map. So yeah, I think TomTom is really a big data company, but just collecting the data, that's not so interesting. It's what you do with it. Well, to give you some more insight, where does the data come from, is to explain quickly that TomTom is built into 3 pillars. We have automotive, enterprise, and consumer. Well, consumer is the old TomTom. It still exists. We still deliver navigation devices, and we build smartphone apps. For example, the Go Mobile and AmiGo app. AmiGo is a free app used for navigation. But the other solutions that we provide are for automotive and enterprise. So with automotive, you need to think about customers like BMW and Daimler taking our digital maps and traffic information and embed that in their dashboard for navigation purposes. It's not TomTom branded, but it's hidden kind of behind the screen. And with enterprise, we mean that we also deliver and receive data from companies in fleet management industry, but also ride hailing. Uber, Microsoft are customers of TomTom using our digital maps and traffic data, but we get data back as well. So from all the 3 pillars, we constantly receive GPS data to power our solutions. And as you can imagine, when we talk about a lot of data, some numbers, we deliver our traffic services in 80 different countries, obviously including India and Russia. In total, we have about 600 million devices that contribute to our traffic services in the 80 countries. And if we accumulate all the distance that we collect every day, we can go to Mars 9 times a day. So it's really a lot of data that we receive. Well, that's all interesting. I think this is more interesting because when we capture all of the data and we put it over a black sheet, so this is not a map, this is a black sheet where we put all the GPS data, you can nicely see that we capture data everywhere where people use connected services, connected cars. So here in India, you can see the more red the color is, the more data is captured. So you can perfectly see all the cities like New Delhi, Mumbai, Bangalore, Pune. It's all indicated red, means there's a high density of data collected. But also outside the urban areas, we collect data. So you can see we nicely cover all regions in India. Well, the fact that we collect data is fun. We can make pretty pictures, but it's about what you do with it. And one of the things we do with it is make traffic index. So this is a yearly overview whereby we benchmark all of the big cities around the world. And what we do is we look at the drive times in the middle of the night and we compare it with the drive times in rush hour. So based on that, we get a pretty good idea about how congested is a city. Well, this is the overview about 2020, which we published earlier this year. And what you can see is that 3 cities, Mumbai, Bangalore, and New Delhi, are part of the top 10 of most congested cities in the world. And if I take Mumbai, then you see the average congestion level of 53%. So what that means is that an average trip in Mumbai in rush hour takes you 53% more time than doing the same trip in the middle of the night at ideal driving conditions. As you can see, Moscow is actually the most congested to this overview, but Mumbai, Bogota, and Manila are actually really close as well. Of course, due to the pandemic, 2020 already shows differences to 2019, which is pre-COVID. But yet, I think this means there's some work to do in India to bring this congestion level down. The fact that India has 3 cities in the top 10 is not good. That should definitely become better. And we have some interesting solutions we can offer together with Sistema. Well, let's discuss that a bit in detail. Before I talk about traffic, just quickly, I explained about GPS data. We make this interesting traffic index with it. But to give you a quick sneak peek, is what we do with it is, first of all, we make maps with all that GPS data. So when we see lots of cars driving over streets that's not in our digital map, it automatically starts changing an intersection into a roundabout or adding geometry. So this allows that we can update our digital map weekly to really make sure it's up to date. We use it to deliver state-of-the-art navigation software, not the topic of today, but a key part for our automotive colleagues. We make traffic information, real-time historic, and we'll go into detail there. And we have different layers for automated driving. So of course, an automated vehicle or partly automated vehicle has lots of sensors, but it also needs a highly accurate digital map, lane counts, and what have you, to make sure that it can position the vehicle as detailed as possible so it can perform all of the functions that are needed. Well, let's go a bit into detail about real-time traffic. Let me now show you my most techy slide of the presentation, so don't worry about it. But this is the TomTom Traffic Fusion engine. And to explain, this all started in 2007 when we launched the traffic service in the Netherlands. That was the first country. That Fusion engine evolved in all of the years further and further, adding new sources, adding new algorithms, adding artificial intelligence to a state where it's today, where we deliver it in 80 different countries around the world. Well, to give you the high level overview, on the left side, you see the inputs. In the middle, you see the Fusion engine. And on the right side, you see the solutions that come out of it. So let's start with input data. Of course, I spoke about GPS data or probe data, as we call it. Of course, that's a very important part of our Fusion engine. And what we do is we map match all of the GPS data to our map. We filter things out. We filter duplicated devices out and what have you. And then that's a base layer whereby we know the speed throughout the road network. What we add on top of that is that we also have a historical speed profile. So we know also from a historical point of view what the speeds should be. We started to use sensor-derived observations. So these are cameras that are in the vehicle that are capturing, for example, road signs or roadwork messages. We use journalistic data. This normally comes from government saying, hey, this road will be closed as of tonight, or there's an accident here and there are 2 lanes closed. That's information we receive from official sources. And we use community input. So I mentioned the TomTom AmiGo app, which is a free smartphone app. But when you use it, you can also report a hazardous location or set of roadworks. And all of the input that people give directly goes into the Fusion engine. So inside the Fusion engine, we mix all of that source data together. We validate it, we enrich it, we ignore it, depending on where it comes from, and then we make something out of it. And to give you one example is, throughout the world, we receive many road closure messages, but with our GPS data, we can check if that road closure is really there. Sometimes we receive a road closure message, but the road is not closed at all. So then we remove it, or sometimes the position is not really right. Or actually, most of the times, we don't get it reported, but we measure that all of a sudden there's no GPS data anymore. So after a while, we say, well, then the road is probably closed. So we proactively close it automatically in our Fusion engine. And the same we do with roadworks. And of course, that's also how all the jams work. So we receive the data and precisely define where's a traffic jam. Well, what comes out of it? Two products that are relevant here. Let me actually show you. One product is what we call traffic incidence. So traffic incidence provides you information about a jam. So position, delay time, length. So you see one example there, one Indian example, a short jam of 800 meters with 4 minutes of delay. But there's also information there about roadworks, about road closures, about hazardous locations, etc. This information is typically used in navigation devices, right? So you're not interested if there's nothing to report, but you're interested if there's a delay, because then you can update the estimated time of arrival, or you can even change the route if needed. What's interesting here for traffic management purposes is that we also have turn-specific traffic jams. So let's say there's a jam on that street, but it's actually only for traffic that turns left at the intersection. Well, in that case, we kind of make sure that it's only used if you turn left, and if you go straight on, you don't use it. We also have jam tail warnings. So when there is a traffic jam, the speed in the tail of the traffic jam is really slow, but the speed of the traffic approaching is really high. Then we issue an extra alert, because the most nasty accidents happen in that tail of the traffic jam. So we issue an extra alert saying there's not just a traffic jam there, but it has a dangerous traffic jam. This traffic solution is mainly used in logistics, in navigation, in asset management kind of solutions. The other product we make out of it is what we call traffic flow. And traffic flow is not just about traffic jams, it's actually reporting the state of the entire network, also when it's in free flow condition. I know it's a bit tiny, but you can see there one example in New Delhi, whereby you see for the tiny road segment, you can see current speed is 25 kilometers an hour, free flow conditions at 33. You see the current travel time and the historical travel time, the free flow travel time. And you see a quality indicator, because of course we report what's the quality of that information. If we have many GPS devices, but they all show a different speed, then the standard deviation is high, so the confidence is a bit lower. Or maybe in the middle of the night, there are not that many traces, and then we also report a lower quality indicator. This solution is typically used by traffic centers because they want to know the state of the entire network, maybe of the highway, but also the diversion routes, etc. So then this solution comes into play. So traffic incidence, traffic flow, the two key products there. Well, to give you a quick, I don't know, it's pretty full slide, but these are different customers of our traffic service. Using many automotive brands that use it in their dashboard. But maybe for this webinar, what's interesting is to highlight some of the more governmental users. Maybe one example is the Autobahn. This is a German entity responsible for the management of all the Autobahns, all the motorways in Germany. And they use the real-time traffic data from TomTom to run their traffic operation center. But they also use our historical analysis to kind of measure the performance of the key routes in Germany. Another customer of us is the city of Brussels. They changed the speed limit from 50 kilometers an hour to 30 kilometers an hour, and they used the historical data from TomTom to assess the impact. Many people complain about it, but they use this data to kind of understand, like, is the complaint valid, or is it like a perception of someone rather than proven by data? But also a fun fact, in Brussels, they deployed pop-up bicycle lanes because of COVID to allow for more social distancing. So they sacrificed some roads, lanes for a bicycle path. And they're now evaluating with the TomTom data, what was the impact? Are we going to make it permanent or not, etc. But we also have other customers like Maine DOT, the state of Maine in the US, or the city of Frankfurt and Düsseldorf that use the traffic data in their traffic management center to run their daily operations. What's important to mention here, and that's why we're on this webinar, is TomTom has all of these solutions for 80 different countries. But as Ayush Agrawal already mentioned in his webinar, traffic management also means a lot of customization to make it tailored to the needs of the specific city. And this is why we work with local partners who really understand the market and the request from the end customer in order to deliver the data. So what we already saw in the other presentations is knowing about the state of the traffic is great, but you also want to know the state of the traffic signals and the weather stations. And I think the beauty is that you kind of embed the traffic data with the other sources to have a common operational picture and to run out of that. Well, to wrap up my presentation, I want to show you one latest innovation we added. It's a new solution. It's called Junction Analytics. It's a solution whereby you can measure the performance of a junction with or without traffic lights based on GPS data. The solution is really intended to be mixed with hardware, with infrastructure data. It has an API, and yeah, well, let me actually quickly give you some examples. So first of all, you set up the junction, very simple, by drawing a little bounding box over the junction, so you know each approaching road and each exit. So in this case, you see a very simple New Delhi intersection, 4 approaches, 4 exits. Well, then when it's running, you can actually start monitoring for each arm of that intersection some key attributes. What's the delay? What's the queue length? And this is important, right? Because with the sensors, with the video or the loops, you have a horizon of maybe 100, 200 meters, but sometimes the queue is 500, 600 meters long. With floating car data, we can actually capture that. Also, if there's no loops or camera at all, we can still capture what's the delay. We also look at what's the average stop. So how often does a vehicle need to stop before passing through the intersection? And we also look at the number of vehicles and, most interesting, turn ratios. So out of that intersection, how many % goes left, straight on, and right? We update this in real time. We also have a little history. So what you see on the left side is an intersection where you nicely see the delay time for one specific arm. You can see in the middle of the night, it's quiet, but in the rush hour, it's delays up to 260 seconds. And it allows for very interesting new solutions. For example, optimizing a traffic model based on actual turn ratios. One last example here. This is an intersection here in the Netherlands where I'm based. This is actually not an intersection. This is a roundabout without traffic signals. And the beauty of floating car data is you capture data everywhere. So also on locations where there's not even a traffic light, but people complain about it, we can now measure easily what the problem is. And in this case, we could see that a Friday in the afternoon rush hour, the queue length was about 800 meters for this roundabout. So it really allows for better performance of locations where there's no hardware, and you can prove it. Well, anyway, that's the latest innovation. For more information, please get in touch with SIMETRA. I want to thank you for this brief presentation, and curious if there are any questions.